costs significantly. 30%, I think, is the number that they're saying. And not only development costs, but recurring costs. You make these tanks, it doesn't have to go into an oven.
The way it works is a fiber placement head on a robot is programmed to lay down the material exactly where it is needed. This new process reduces costs, time, and most importantly, produces a better product. Because all of this technology is relatively new, the NASA team is using a process called the building block approach. First, they test small coupons or pieces of the material to make sure that it can measure up to expectation. Eventual goal to build a full-scale tank to fit on a launch vehicle. The current 2.4 meter section is located here in this silo in the west test area at the Marshall Space Flight Center, under the shadow of test stands for the Apollo engines. Engineers have placed a foam coating over the tank and will then test it in a way that would be expected on a launch vehicle.
We put the tank through the exact conditions that it would see in the launch vehicle. So we fill it with the cryogenic material, in this case it's liquid hydrogen, and then in the case of a launch vehicle, we may have to empty that. So we would fill and drain, pressurize, unpressurize, all to determine how the tank reacts to those conditions and loads.
With this test completed, engineers can look for problem areas, fix them, and then move on to building the larger tanks. And if successful, this game-changing process can be adapted to other parts of a launch vehicle, making it more lightweight and less expensive. These are just a few of the ideas that are being worked on by the Game-Changing Development Program Office. But many more innovative ideas and technologies are being moved through the game-changing lane each day. And with each new development, change is coming to NASA that is allowing the agency to rapidly infuse technology and make smarter decisions about how to move forward and create different approaches while changing the culture. Much of the credit for this positive change can be placed directly at the feet of Space Technology's Game-Changing Development Program Office.
Personally, I would love if 5 years from now somebody said they really changed the game. They made a difference for NASA. That's all I'd need to hear.
The reason that you would do any kind of experiment in space is if there's something particular about the space environment, and most often that is microgravity. So mostly the ISS gives us the ability to either do something that we can't do in a facility on Earth or investigate some phenomenon, some property in a way that we can't on Earth. So for example, some of the tissue architecture, these really delicate tissues, as you start to build them up, they would collapse because you have gravity, or the cells would naturally settle to the bottom of the plate. And so you just can't study the answer to the question that you're looking for. So the space station lets us have that ability to either test what the effect of gravity is or remove that problem entirely from our experimental setup. Yeah, the space station's an incredible place to conduct research. It was sort of like being in the world's most amazing lab when I was up there in 2016. So when you're a scientist, you're used to working on one thing over and over and maybe really refining the details on that over the course of a PhD thesis or a lab project. On Space Station, you get somebody's incredibly refined project times 200 different fields. So for me, it was a chance to learn